Analysis topic video 3. First two of my videos dealt with positive ions, identification of positive ions using two methods, either adding sodium hydroxide or flame tests. Well, today we get on to negative ions. Negative ions, how do we identify those? Well, there are three tests you need to learn, and the three tests are capable of proving you've got 5 negative ions. If they're present, these tests will come out positive. So to test for chloride, Cl-, bromide, Br-, or iodide, I- ions, then take a little, and what I've done is today, when I start demonstrating, I've dissolved, we're going to use solutions. We've dissolved soluble versions of a chloride, bromide, iodide in water, and that frees up the ions, and then we can test for them. We add nitric acid. Now, you need an acid to stop any false positive tests. If you put the acid in, only then will the test be for chloride, bromide, or iodide. You add silver nitrate, that's the main chemical. Silver nitrate chemical is used to react with chlorides. You get a white precipitate with bromides, you get cream precipitate with iodides, you get a yellow precipitate, and they're precipitates of the silver versions of those ions. So silver chloride is white, silver bromide is cream, silver iodide is yellow, and that's why you need silver nitrate, because it gives you those vital silver ions that you need. So that's one test. Test A is one test, and it will do for you 3 different negative ions. That just leaves 2 more. Now, sulfate, SO4 2-, and carbonate, CO3 2-, those ions are tested for in these next 2 tests that are on the board. Sulfate. Well, again, you've got to add nitric acid or acid to get rid of any ions that may mess up your results. But you cannot use sulfuric acid. That's why I put nitric acid there. We want an acid that's not sulfuric, because sulfuric acid itself has sulfate ions in it, H2SO4. SO4 2- ions are present in sulfuric acid. Don't use that. But use nitric acid to stop any false positives, or you could use hydrochloric acid. That would also stop any false positives. But then the main chemical to use is barium ions in a thing called barium nitrate. Now, when I looked for barium nitrate in my cupboard, I couldn't find it. So I have in my demonstration I'm going to use barium chloride solution, because I found that in my cupboard. Barium chloride and barium nitrate, both of them have barium ions present. And that's what will react with sulfate ions, making barium sulfate, which is a white precipitate. I'll summarize what you should learn later. Carbonate ions. Now here we use that famous reaction. We use a reaction where acid and carbonate make salt water carbon dioxide. And the important thing about carbon dioxide being given off is you see fizzing. So if you take a little test substance, add some acid, and I put nitric acid to make it easy for you for all 3. If you use nitric acid there, and there, they'll work. But you can use any acid, because any acid with carbonate ion will fizz. And we look for fizzing, the posh word for fizzing being effervescence. If you observe effervescence, then it's going to be a carbonate. Now, you could prove that by bubbling the gas through lime water and getting the lime water to give you a white precipitate with this carbon dioxide gas. If you prove it's carbon dioxide gas, then the proof is that that carbon dioxide gas came from carbonate ions. And therefore, you need to do that. But at GCSE, just fizzing is enough for us to think, oh yeah, fizzing, salt, water, carbon dioxide is being made. It's an acid carbonate reaction. Acid carbonate, therefore carbonate ions are present. I want you to know both though. I want you to know fizzing is enough, but to be doubly sure, you would take the gas, bubble it through lime water. Right, I'm going to show you these tests next. So here I've got my setup. This is a boiling tube. I use boiling tubes for demonstrations because they're a bit bigger. Now when you use normal test tubes, you only need a little bit at the bottom. Boiling tube obviously takes a bit more because I'm demonstrating. It's fine for you to use small quantities in normal test tubes. Here I've got the nitric acid. So this is crucial to me to stop false positives in a lot of these tests I'm going to do. Now the first test, let me do carbonate. Carbonate, sodium carbonate. That's clearly got sodium ions in, carbonate ions in. If I did a flame test on that, the flame test would give me orangey yellow for sodium. But we want to test the negative ions. Put a little bit of that in there. Nitric acid. Acid with carbonate gives salt, water, carbon dioxide reaction. So when we put it in, we should see fizzing. See that? The fizzing there tells you it's a carbonate. To be doubly sure, you could collect that gas, collect the gas that came off, and bubble it through lime water. I'm not going to do that. I'm not going to do that because the main thing I want to focus on is the reaction that's happening there, the reaction that gives you carbon dioxide gas, and I'm going to deal with that when I carry on with my PowerPoint. Another test tube. So the nitric acid was all you need, or any acid, all you need to test for carbonate. What about sulfate? Sulfate, here. Magnesium sulfate. It's got magnesium ions and sulfate ions. Now we cannot identify magnesium ions with flame tests or with sodium hydroxide. So if you were given this in an exam, you could only identify the sulfate bit. You could not prove it was a magnesium sulfate. But this demonstration, we want the sulfate. We want to prove the sulfate bit. There we go. There, you've got some sulfate ions, magnesium sulfate solution, and then we want to do our test. Well, this chemical here, barium nitrate, or barium chloride in this case, barium chloride, it's the barium ions that are going to react with the sulfate ions to give a white precipitate. But there is the chance of other ions giving us a white precipitate. So we need to take an acid and add acid first. Actually, it doesn't matter whether you add it first or later, but acid must be added. And only then, if you see a white precipitate, is it a positive test. Watch. That's a white precipitate. You can't see through that. There's pieces of solid blocking your vision. Therefore, that's a precipitate. That's a solid made in the reaction. As a function of the solid made in the reaction, that's a white solid. We know it has to be barium sulfate because the acid will destroy any other ions that may have given you this positive test. So, acid and barium chloride we use this time. Barium chloride, but barium nitrate is fine. Anything with barium ions in, barium chloride, barium nitrate, both have barium ions in, and therefore we can use either in testing for sulfate like that. Next one. Next one, the important chemical here is silver nitrate. And again, we're going to use nitric acid. We're going to use nitric acid to stop any false positive tests. And we're going to test a chloride. Here, I've got calcium chloride. So chloride ions. I want to add this, but I'm going to add some nitric acid to stop the false positive tests. And then I'm going to add silver nitrate. See? That is a white precipitate. The only thing that will do that is a chloride ions being present. And of course, chloride ions are present in a chemical that we use calcium chloride solution. So chloride ions there give you a positive test, and that's entirely what we expected. So chloride ions are proved like that. Then what about bromide ions? Well, bromide ions, we do exactly the same thing. Indeed, all of these halide ions, as we call them, ions of group 7 halide ions, they all, 3 of them, chloride, bromide and iodide, you do exactly the same thing. So this is where we think we got bromide. Yeah, think we got bromide. Add acid to stop any false positive tests, and then silver nitrate gives you a cream. Now you might not see that on the video, but this is a cream colour. Cream as opposed to white. So white for chloride, cream for bromide. So this is silver bromide. What we had before was silver chloride. Silver chloride is white, silver bromide is cream. And finally, how about iodide ions? Well, we do the same thing with iodide ions. We've got here potassium iodide. Put a little potassium iodide in. Then nitric acid to stop any false positives. Then silver nitrate gives you a precipitate of silver iodide, which is yellow. Yellow silver iodide, that one is cream silver bromide, and that one is white silver chloride. Now, I know it's not so easy to see the colours, and that's why at A level we add ammonia at the end to check which is which, but that extension with ammonia is not part of GCSE. So GCSE, we just learn those 3 colours, white, cream and yellow, and they tell you whether you've got chloride, bromide or iodide, because silver chloride is white, silver bromide is cream, and silver iodide is yellow in colour. Let's carry on with our PowerPoint. Carrying on then, learn those tests. You need to know those tests. Testing for the 5 ions I've just demonstrated. And then if we put them in the form of a table, carbonate, sulfate, chloride, bromide, iodide, learn how to do them, and then what do we see happening, and when we see the observation, what it means. There, that's the table filled in. With carbonate, we get fizzing. The gas gives a white precipitate with lime water. The carbon dioxide proves you've got carbonate ions present. With sulfate, if you do that, Then with sulfate, you get a white precipitate. The white precipitate is barium sulfate, and that precipitate proves you've got those sulfate ions present. Similarly, with these three, you do the same procedure, but then if you get a white precipitate, cream precipitate, yellow precipitate, it tells you you've got silver chloride, silver bromide, silver iodide, and the silver chloride can only be obtained if chloride ions were present, or if bromide ions were present, you get the cream precipitate. If iodide ions were present, you get the yellow precipitate. So you need to know the observations and know what the observations mean. And then finally, I want to explain it to you, and I want you to be able to write an ionic equation for each of these reactions. Fundamentally, the ionic equation will tell us clearly what is being made. Just pause that for a minute. Carrying on. So I want you to understand that when we do that test for carbonate, it's the hydrogen ions from the acid that react with the carbonate. The ionic equation, look, hydrogen ions from the acid react with carbonate ions that are in the unknown, and they will make, that's balanced, they'll make carbon dioxide and water. That's why carbonates react with acid. They make carbon dioxide and water. All the other spectator ions make the salt. Now sulfate, what's happening here is from the barium nitrate or barium chloride, the barium ions react with the sulfate ions. And that ionic equation tells you precisely what's going on. Barium ions and sulfate ions make barium sulfate precipitate, which is white. White precipitate of barium sulfate. The halide ions, chloride, bromide, iodide, they in turn react with silver ions from the silver nitrate solution that you were using. Silver ions react with chloride, bromide, iodide, making silver chloride, which is white, silver bromide, which is cream, and silver iodide, which is yellow. And there you've got the five ions that you need that are negatively charged. Now, all of that might seem a lot of faffing around and a lot of learning. But, if you want to do well, you're going to have to do some learning. And there is not that much learning. There's not a lot of faffing around. You need kind of like to summarize things and organize things in your head so that you can remember them in a successful way. And I'm going to put up a summary now to help you see all of this topic on one slide. And it'll show you that it's not a huge task. It's a manageable task. Okay, it's a challenging task. You have to learn things. But before I get onto that slide, summary, learn the tests. Understand what reaction is happening. Write ionic equations. And understand that your addition of acid will prevent any unwanted false positive testing. All of that is covered on my previous slides and my whittering on, me talking over the reactions. So to summarize everything, I'm going to do it here. There. Sodium hydroxide. You had to learn 5 ions. Remember, you add sodium hydroxide and then you add to excess. With that, you got a green precipitate. With that, you got a brown precipitate. I've summarized around this table. So that was one procedure for working out positive ions. The other procedure was flame tests. These are the colours of the flame tests. And the negative ions are on this side. With dilute acid, you can identify carbonate. With barium nitrate and nitric acid together, you identify sulfate. With silver nitrate and nitric acid together, you identify chloride, bromide, iodide, and I've written in the observations in my own handwriting across the top. That to me is the summary. So you've got to learn how to do these things. But then that one slide summarises what you need to learn in order to be able to do and successful answering of questions in the future and be successful with your GCSE answers. So that's it. That's, I think, the end of the analysis topic. Learn the reactions, learn the observations, understand it, and then do lots of questions that you've got on analysis, either end of chapter questions or past paper questions on analysis. You should be able to do them, and only when you can do questions should you ever feel confident in any topic that we're dealing with. Okay, see you next time.